2.6 proofs. We have algebraic proofs. They are a list of algebraic steps to solve problems where each step is justified. That's an algebraic proof. And we need to go back to our properties that we learned in algebra. This is, I believe, 1.2 or 1.3 in algebra. We have the addition property of equality. What does that mean? If we have an equation a is equal to b, then we can add the same number to both sides of the equal sign. That's called addition property of equality. Then if we subtract the same number from both sides of an equation, that's called the subtraction property of equality. If we multiply both sides of an equation, that's the multiplication property. And if we divide both sides, it's the division property. A is equal to A is the reflexive property. Not used very much, but will be used in our geometric proofs in the future. We have the symmetric property, which states that if A is equal to B, then we could flip that equality and say B is equal to A. We have the transitive property, which is if A is equal to B and B is equal to C, and that's given, then we can say that A is equal to C. We have the substitution property, which states that if A is equal to B, then we could replace A with B in any equation or expression. And we have the distributive property, which is A times the sum of B plus C is equal to A times B plus A times C. So we're distributing out the A. So we need to use these algebraic properties in our proofs. Now, how do we set up our proofs? They're going to go ahead and give you a given, right? So this is our equation. And then we need to prove that x is equal to 4. So when we're setting up our proofs, we start with the given, right? So we have statements and reasons. We have 2 columns. And we start with our given. And then we end with our proof. Okay. And so when we start with our given, the reason for this one is going to be given. Reason's always going to be given for the first statement and reason. And then what are we going to do? We're going to distribute out the 2, so we get 2x minus 2. And what's the reason for that? Well, is it the addition property, the subtraction property, is it the multiplication property? It's none of those. It is the distributive property that allows us to do this. So we're going to go ahead and write distributive property. Oh, my pen broke. Give me a second here. So I'll finish with the pencil. It's going to be distributive property. And when we're writing our proofs, we can go ahead and write distributive as just like dist dot prop. Okay. The next one is, what are we doing? We are taking 6x and 2x and we're adding them together and we're getting 8x. So what we're doing is we're taking what 6x plus 2x is equal to 8x and substituting that in instead of the expression 6x plus 2. So this is going to be our substitution property, right? So if a is equal to b, where a is 6x plus 2 and b is 8x, right? That's true. Then we're substituting in b for a. So this is going to be sub property. Our next one here is we're adding 2 to both sides of the equal sign, right? So we're getting rid of the 2 on the left side and we're moving it over to the left side. And what is that? That is going to be our addition property, where we're adding 2 to both sides of an equation. So I'm going to put here add prop. And lastly, we are dividing both sides by 8. So we get x is equal to 4. And so that is going to be our division property, where we're dividing both sides of the equal sign by 8. So we're going to say div prop, like so. And now we're done, right? We start with our given, and then we end with our proof, and we're finished. Okay, and we've given a reason from the list of algebraic properties for each step of the way. So let's go ahead and do this one. We need to prove, we're given the equation that Celsius is equal to, degrees Celsius is equal to 5 divided by 9 times the difference of F and 32. So we need to prove that, this is actually a typo, there shouldn't be parentheses here or there. Okay. We need to prove that Fahrenheit is equal to 9 over 5 times C plus 32. So what do? We start with our given. C is equal to 9 over 5 times F minus 32, like so. And our reason for that is going to be given. Always given for the first step. Next, what do we need to do? We need to get rid of that 9 over 5. So we can do that by multiplying both sides of the equal sign by the reciprocal. So it's going to be times 5 over 9 times C is equal to 5 over 9 times 9 over 5 times the difference of F and 32, like so. So what are we doing here? Well, we are doing the multiplicative property of equality. So I'm going to put here mul prop. So what do we get next? Well, we're going to get a multiplication here, so it's going to be, I'm going to rewrite this as 5 over 9c. Over here, the 5 over 9 and the 9 over 5 turns into a 1. So what we're going to get is our F is equal to 32. F minus 32. So we're taking 5 over 9 times 9 over 5, and we're substituting it with a 1, right? So that's a substitution property right here. Okay, so we're going to put subprop. And then what are we going to do? We're going to add 32 to both sides of the equal sign. Okay, so I'm going to get 5 over 9c plus 32 is equal to F minus 32 plus 32, like so. And so what are we doing here? Well, we're doing the addition property. So I'm going to say add prop. And what do we get? We will get 5 over 9 C plus 32 is equal to F. And here we're taking negative 32 and positive 32, adding them together and replacing it with a 0. And that there is our substitution property, right? Because negative 32 plus 32 is equal to 0. And because of that, I'm replacing that expression with a 0. So it's going to be subprop. And then lastly, we don't want to prove this. You might feel like you're done, but we're asked to prove F is equal to 9 over 5. So we need to rewrite this as F is equal to 5 over 9C plus 32, our proof statement. And what allows us to do that, what allows us to flip the equation, is our symmetric property of equality, right? So if A is equal to B, we can rewrite it as B is equal to A. So this is going to be our symmetric property. And that's how we write two-column proofs, right? For every step of the way, we need to state which algebraic property allows us to take that step. We start with our given, our reason is going to be given, and then we end with our proof statement.